Hi, I'm Ashay. I'm an engineer by training and a storyteller by passion. I made this podcast to talk about data science, but no math, no equations, just intuitions behind data science. The episodes are not in any particular order, and you can just tune into any episode and listen to something related to data science. Let's get started. Whenever you interact with any business these days, it could be a brick and mortar store or an online business. You are presented with items that you may like, the items that business is trying to sell to you that you may like. And these items are recommended to you, and that's because there is a recommendation system in place in the back end. Now, creating these recommendation systems is a popular problem in data science. And there are two ways to build these recommendation systems. One is an empirical way where you are only looking at the historical user item interaction data and creating a solution for the recommendation system. Or there is a logical way where you know what the user likes, you know the type of the item, and you match the type of the item with the user interest, and you recommend the item to the user. So this episode is going to talk about latent features in one of the logical ways of solving the recommendation systems problem, which is the singular value decomposition. Now let's take an example. Let's say we know that there is a user, Tom, who likes action movies, and we know that Die Hard is a movie which is an action movie. If we know these two things, we can create a logic of recommending Die Hard to Tom because we can match the feature of Die Hard, which is an action movie, to the feature of the user interest in action movies. This works really well if you know the features of users and features of items. However, you don't necessarily know all the features of users and items all the time. Actually, it is impossible to know because there can be so many features of users and so many features of items. Therefore, one of the ways, logical ways of solving recommendation systems problem is singular value decomposition, where you are creating features of users and items based on the historical interaction data. Now, this singular value decomposition word really looks big, but it's a very fairly simple concept. Let's go back to the example of Tom and Die Hard. So let's say we have a historical interaction available of Tom liking Die Hard, and in theory, if you could decompose this information into Tom has interest in action movies, then you have suddenly opened up a possibility of recommending other action movies to Tom, isn't it? Or if you could decompose this information into Die Hard is an action movie, you have suddenly opened up a possibility of recommending Die Hard to users who like action movies. However, just by looking at the interaction information of Tom liking Die Hard, we can't really go back and decompose the information into Tom has interest in action movies and Die Hard is an action movie, because it's not possible. That information is not present in that interaction. This feature of Tom's interest in action movie and Die Hard being an action movie, this feature information is not present in the interaction. However, linear algebra gives you a mathematical way of decomposing this information into some feature of Tom and some feature of Die Hard, and it decomposes the interaction information into these features of users and features and items, and those features are also some numerical entities. So instead of saying Tom has interest in action movies, there is some numerical entity attached to Tom, which is its feature, and there is some numerical entity attached to Die Hard, which is its feature, the movie's feature. And this decomposition is basically singular value decomposition. And the singular value in singular value decomposition is basically the weight attached to the feature. So, like for example, the decomposition of the information can be done in hundreds of features, let's say, and then the SVD or singular value decomposition will attach a certain weight to some features, and not that much weight to other features, and you can choose only the features that have a certain amount of weight and use those features to calc or predict in the missing interactions between users and items. So think of SVD or singular value decomposition as a numerical way of decomposing interaction information into features. And since those features that the interaction information gets decomposed to, those features are not labeled. Like, for example, as I said, we can't really label Tom's interest in action movies and Die Hard being an action movie. The absence of label of those labels for those features basically makes them latent features, but still they are features. And once you have the features of users and items, then suddenly you have opened up a possibility of predicting interactions between users and items in singular value decomposition. I will give you another example which is completely independent of singular value decomposition. Let's say we have a car, and we have a red car, and um, if we are asked to describe features of the car and give weights to those certain features of the car, then let's say the main feature of the car, the feature with which you can 80%, let's say again theoretically 80% of the information can be given to the user about a car. Let's say the feature is a box, and another feature is four wheels at the bottom of the box. So if you just imagine a box and four wheels at the bottom of the box, with this you can possibly guess, if you look at this shape with four wheels at the bottom, you can possibly guess it's a car. So there is, let's say, an 80% weight attached to the feature box and 15% weight attached to the features as four wheels at the bottom. So then only 5% of the information is in the other features like windows, windshield, wipers and stuff. But if you just see box and four wheels, you can understand that it's a car. Now so you can literally create a matrix of features for the car. So let's say you have a column of feature labels and another column of feature weights. So the first label is box and the weight is 80%. The second label is wheels and the weight is 15%. And then there are some other features like windows, windshield, wipers, um, steering wheel, and you have other weights attached to it. Now think of this feature label column completely disappearing, and there are some numbers associated with those features. The weights remain the same, so you will basically know that there are two major prominent features describing the car which have weight of 80% and 15%. And then there are some other features which are at some lower percentage weights. So what this is we basically decomposed the information of about a car into its features. And if you know the feature labels, that means you know the content of the data. But if you don't know the features of the labels of the features, then you basically just know some numerical entity attached to those features and the weight associated with it. But with this information itself, even though those features are latent, you don't know the labels, you can still calculate the information about a car from those features. And that's what latent features are in singular value decomposition. Thanks for tuning in. I made this podcast to talk about intuitions behind data science. And we'll talk about some other idea in the next episode. There will be no math, no equations, just intuitions behind data science. See you soon.